Welcome to DAC Productions. This video is going to be the first in the series on unimproved road building. It will include road grading, building of culverts, laminated nail bridges, box culverts, pipe culverts, and fording creeks. The purpose of this video is to build unimproved roads which will support pickup truck and four-wheel drive traffic and farm machinery. These roads are not designed to support high-speed movement. Approximately 10 miles an hour is as fast as you'll be able to go on these roads. What we're going to do on this road segment is we're going to build a road from the edge of this field joining three existing skidder paths. We're going to improve the skidder paths so that we can get vehicle traffic down it. These are going to be single lane roads. When we discuss unimproved roads, what that means is the road surface will be natural. It'll be dirt grass mixture, and it won't be primarily gravel. Once you start graveling surfaces and putting in 4 to 8 inches of gravel, it becomes an improved road surface. What we're looking here is to try to do as much work with natural available materials as we can. On this project, this first culvert here, the main problem with this culvert is it has 3 intermittent streams running through it. I've already taken and sized the material here. On this first crossing for the road we're building, we have 3 intermittent streams running through here. The owner, before I purchased this property, had taken and driven through here and destroyed the creek beds, and what he ended up with was a intermingled bed here. What we're going to do is straighten these beds and then put plastic ABS piping in. The ABS piping is really good. It's lightweight. One man can work with it and move it around, unlike concrete or steel pipes. What we're going to do here is take a closer look at the creek bed here. That way you can see how continued traffic through soft watersheds destroys the path surface. And what you'll notice here is that the water does not flow through here. It actually ponds and sits here because there's no clear path. During the construction process, we're going to fix this problem, and it will carry the water through in an orderly manner, thereby promoting drainage. This is the first portion of the crossing. There's an intermittent stream here that's approximately 1 foot wide. What we're going to do is install a 1 foot wide culvert size to the area. What you want to do when you're sizing these culverts is you want the pipe to be the approximate size of the creek channel. As you can see in here, this area was churned up by vehicle traffic. There's roots, rocks, all kinds of material here, and you'll notice the water ponds and does not drain. What we're going to do is improve this area. We'll cut an actual channel, lay the pipe in it, and then we will apply natural stone and soil fill. This is the second portion of the crossing. It contains 2 actual creeks. One of them is about 1.5 inches in diameter. What we'll do on this one is we'll put a 15-inch ABS plastic pipe in. You'll notice as we pan that this bed contains a lot of stumps, wood debris. All that will have to be removed. What we're going to do is go through here and paint the trees. Then we'll give you another shot, and that'll show you the area that needs to be cleared in order to put the piping in work. This ABS pipe we're going to be working with comes in 20-foot lengths, and you can cut it down, or if you need a longer section of pipe, it has plastic connectors you can use to make whatever length of culvert you need. The path that crosses, that uses the least amount of pipe, is one that is perpendicular to the root and parallel to the creek. This would use a minimum amount of pipe. As your angle approach to the creek gets closer and closer to parallel, you'd use more and more pipe. So what you want to try to do when you're designing these crossings is to try to minimize the pipe to help you on your expense. This is a view back across the crossing from the other direction of travel. Here you can see the amount of drop and how low the creek bed actually is. It's going to take quite a bit of fill and rock to fill this culvert in. One thing we'll do is use the 15-inch pipe to help us gain as much height as we can. This will minimize the amount of fill we have to bring into the area. On this side of the crossing, we're going to go into a Y intersection and connect two roads to it. We're going to try to have one crossing, and therefore we won't use as much material or spend as much money. What we're looking at here is the four most common sizes of ABS culvert pipe. Starting on your left, we have the 15-inch. There's two types of this pipe. This is the heavier internally corrugated pipe. There's another product that's made that has a smooth interior. You want the one like this that's corrugated inside and outside because it supports more weight. The next one here is a 12-inch diameter. Then we have here a 6-inch and a 4-inch. On projects we're working on, I would highly recommend that the 6-inch be the smallest size you use. At your garden or hardware supply store, there's also a 3-inch pipe of this type. I would recommend staying away from the 3 and 4-inch on projects such as we're doing here. What you're going to find with culverts is the smaller the pipe diameter, the easier they are to clog. And as a consequence of that, it's very hard to clean out small diameter pipes. You have to use a metal chunking rod. And with a 20-foot culvert, you're not going to be able to dislodge the material in it, which means you'll have to dig up and replace the culvert. You'll notice that the larger pipe comes in 20-foot lengths. The smaller 6, 4, and 3-inch pipes, you can buy those in 10-foot lengths, or you can buy them in 100 or 350-foot coils. If you're going to use a lot of the 6-inch pipe, it would benefit you to go ahead and buy the coil and go ahead and cut the pieces for as long as you need them. That would save you on couplers. These are the type connectors that you buy for putting together the larger ABS culvert pipes. And what you'll notice on these is it's pretty much use zip ties on them. This is a really good product. It's easy to install. All this material is lightweight. One tip I'll give you on buying this pipe, if you're going to buy 12-inch or 15-inch pipe, buy the bulk for all of the projects you think you're going to use for a significant amount of time, because they'll charge you a delivery charge. If you have a trailer or a truck that can haul the pipe, that would be much preferable, because usually it runs around $30 to $60 for delivery of pipe. This ABS product is also available in sizes, in excess of 6 foot in diameter. So if you have creeks that are substantially bigger than what we're looking at right here, and we'll have examples of those type of creeks further down the road here. We're going to build a road and put culverts in over approximately a 1 mile long road. And these are extremely easy to install. They just hook over the ribs and fold up. They're very easy to install. Even with 3 or 4 sections of pipe hooked together, the material is still very light and will allow you to work it very easily. When you're working with ABS pipe, it doesn't have the load carrying ability that RCP, reinforced concrete pipe, or metal corrugated culvert pipe has. You want to make sure with this product that you have at least 2 to 3 foot of dirt cover over the top. This pipe works by what's called earth arching, and what happens is, you can see here you have an arch on the top of the pipe, and this allows you to split the downward force. So when you're driving over, you're distributing force at a 45-degree angle like this. As your dirt cover on top of this pipe increases, you start shedding force on the fill dirt around it, and you're not even impacting the pipe substantially. So the heavier the vehicles you want to use here, if you're going to use log skidders, large tractors, or if you're in a military environment where you're operating APCs or tanks, you'll have to have at least 3 or 4 foot of dirt cover over these products. We want to take a look at right here real quick is some of the different types of adapters and connectors you'll find for these products that'll help you out when you're combining pipe or joining them together or building French drains. The first product that we really want to look at is Y connectors. For the 6-inch and 4-inch pipes and the 3-inch, which we don't have examples of here, you have snap-on Y connectors. And they're very handy to combine channels, especially if you're building French drains to drain wet areas, or you bring in low flow into a larger pipe. Now, these products are much harder to get for the 12-inch and 15-inch pipes. They would be a special order item. These two sizes you can find in any garden or hardware store. Next thing we want to look at is end caps. These end caps just fit right on the end here. And what you'll notice is on this 4-inch pipe, this is a slotted version instead of a solid version. This one is designed to leach water from a French drain and drain it away. For this application, the 4-inch and 3-inch pipe is excellent because you can drain a large area, bring it into T's, and then size the pipe up into a bigger drain as you go. That saves you a lot of money and effort in putting them in. Because one thing you'll notice is the bigger the pipe size, the deeper your trenches have to be. So you can save a lot of time and effort using a 4-inch pipe to do various drainage projects. Now, what you want to do when you're putting a French drain in is it's going to be buried under the ground. So you're going to want to use these end caps to keep dirt from getting in these pipes. If you're in an area where you have a lot of sand or silt in your soil, you're going to want to get what's called a pipe sock. And that pipe sock will go over the outside of this. And what it'll do is keep the small material from going in the slots in this pipe and clogging it up. While we're looking at the 4-inch pipe, we'll look at the 2 types of connectors. Here we have an insert connector. And what this does is it has snap ribs on it. And when you put these together, they go inside the pipe. So if, this is an application that's very streamlined, and basically it's personal preferences to which you want to do. This is actually easier to install. The other type of connector is the outside connector, and it fits over the outside here. And on small pipe sizes, they're pretty easy to apply. Once you get into a 6-inch pipe, it takes a little bit more effort to put these on. But I've used these 2 in the past, and they're pretty much interchangeable as to what you want to do. When you're buying pipe like this, you'll find out that it comes in 2 styles. You can see on this end that it's a full diameter open end with a 4-inch inside diameter. But on the other end of this pipe, it has connection cleats, just like this connector does. If you buy pipe sticks like this, they come with everything you need to hook them together. You don't have to buy an adapter. You see this more in the slotted drainage pipe, but I've seen the solid pipe and the slotted drainage pipe both come in this style and in the style of the other end where you need a connector for both sides. Another accessory that is very handy is the 6-inch to 4-inch adapter. And what I've done on a lot of projects is when I'm putting a drain field in to drain an area, for instance, if we're building a road through here and it's a wet area that doesn't drain well, you can take the 4-inch slotted pipe, lay it down in a drain field, bring it together in several Ys, and as you come down and you increasing the amount of water that's flowing through the 4-inch, you can actually step those drain fields up to a 6-inch pipe. And this will help you save on money and installation costs. We're going to go ahead and get started on this first culvert. And what we're going to do on this first one is we're going to use hand tools to build it. And we're going to show you that using your standard hand tools that you'd have around home or your farm, you can actually put these culverts in. These are small culverts, so the biggest pipe size we're going to use would be a 15-inch. As you get into larger and larger size pipes, it becomes more and more necessary to use vehicles or tractors or a bobcat to help you with the fill because of the volume and amount of it you'll be working with. But on this first culvert system here, we're going to use all hand tools. And to get started, the first thing we're going to do is we're going to paint the trees here that we need to remove in order to have the room to work on the site. We're going to straighten the approach road a little bit and kind of clear out and do some grubbing and stuff. So I'm going to go ahead and mark everything, and then with this paint. And as far as paint selection goes, if you're going to be cutting this stuff, you can go ahead and use marking paint, which is temporary, or you can just use whatever bargain paint you can find at the store. But I would definitely mark what you're going to cut. That way you can stand back and look and make sure it's wide enough for you to get whatever vehicles and equipment through that you want to use. When you're looking at the clearing limits of a road or culvert system, you want to look up to the top height of the vehicle, because what will happen is as you drive down these roads, overhanging branches can hit and tear up your vehicle. But the most important consideration is if you're driving a tractor down one of these roads and you get hit by a branch and knocks you off the vehicle, it's a severe safety hazard that can lead to death. So what you want to do is go ahead and mark your clearing limits so you have a safe road. Now what I've done here is I've gone ahead and marked with orange fluorescent paint the clearing limits on what we're going to cut down. In front of the area of activity here, I put a 20-foot piece of 12-inch diameter pipe. Gives you kind of an idea of the width of the area we're working on. Our clearing limit's approximately 30 feet wide. What we want to do here is you need to understand that you don't want to pipe the exact length of your crossing area. When you put fill on top of the pipe, it's going to have to come up at a 45-degree angle from each end. So if you put 3 foot of fill on top of the pipe, you need to have 3 foot of pipe on each side of your road in addition to the road width. Now, what I'm going to do is put a piece of pipe in front of a pickup truck, and it'll give you an idea of what the width of the pipe will look like with the pickup in front of it. What I've done here is placed 2 sticks of pipe in a pickup truck in front of our clearing limits. What we're illustrating here is the width of the 30-foot cut behind us. The first pipe here is a 20-foot culvert pipe, 12-inch in diameter. What we need to look at is the type of vehicle and your road width that you're going to operate over. Use this information to size the length of pipe you need. Back at the culvert back here, I took and measured the depth from the creek bed to the fill height of the road surface. That distance is approximately 4 feet. What we need to look at is, this is one of the primary vehicles I'll be using on this road. This is a 1969 F-250 pickup truck. It's approximately 8 foot wide. I'm going to size my road width for 12 foot. That way I can operate machinery, dump trucks, pickup trucks, skidders, etc. on it. You're going to want to size your road width to handle whatever type of equipment you want to use across here. If this is a military application and you're using HEMTs or tanks, you're going to want to size the road width quite a bit wider. You're probably going to want to have a single lane 20-foot road and base everything off of that if you're using bigger equipment. The turn radius of the vehicle is an important consideration in road width. If you're operating larger equipment, the turn radius is going to dictate whether you can operate the equipment or not across your road bed. You don't want to end up with a long stretch of road that you can't navigate with the vehicle that it's intended for. Looking here at this 20-foot, 12-inch pipe, what we're illustrating here is I need 4 foot of fill on top of my pipe in order to reach the road surface height I want to be at. What this tells me is I take and calculate my pipe length by taking the width of the road, which is 12 foot, and then on each side of the vehicle we need to add the fill distance. When you're placing fill in from your road surface down to the pipe, you want to have a 45-degree slope. This is also known as a 1-to-1 slope. That means that every foot of rise, you have 1 foot of run. So what that means is if I come up 4 foot with fill, I'm going to need to bring it down like this 4 feet. So what that tells you is when you size the length of this pipe, I have 4 foot of fill. That means on each side of the pipe I need 4 foot for the fill to go on to bring it up to the height and make sure that it's stable. So what I need to do is take my 4 foot from each side, add it together. That gives me 8 feet. Then I take my 12-foot road width and it tells me I need a 20-foot pipe. In this case, if my height of depth was 5 feet, that would mean I would need a 22-foot pipe because I would need 5 foot of additional pipe on each side of my 12-foot road. What I've done right here is put a 10-foot stick of 6-inch pipe, and this illustrates a fallacy that you hear a lot at supply stores and by people that have not been in the road building business and have not done a lot of this work. They'll tell you to buy a 10-foot culvert pipe, put it in, and it's no problem. What you'll notice here is you only have 1 foot of room on each side of the tire of this vehicle with a 10-foot pipe. What that means is that limits you to 1 foot of fill, which is not enough to cover this pipe and support vehicle weight. So don't fall into that trap of getting not enough pipe. You're always better off getting too much pipe, and that allows you a gentler fill angle when you're putting your fill material in. And the more gentle the slope on your fill, the more stable it is and long lasting it'll be.